next 7.4, which is more multiplication properties of exponents. And we're going to raise a power to a power, okay? And we're going to raise a product to a power. So here you can use repeated multiplication to simplify a power raised to a power. So here, you see there's a power inside. It's x to the 5th, and it's raised to the 2nd power. Okay? Now, to figure out a rule for this, we're just going to expand it out. So x to the 5th, if I take x, that whole thing, because remember the exponent on the outside is connected to the parentheses, right? So that means that everything in the parentheses is to the 2nd power. You see that? So this would be equal to x to the 5th times x to the 5th. Okay? Now x to the 5th is x times x times x times x times x. Everybody with me? So this is x to the 5th times x to the 5th. All of those x's. Okay? So if I wanted to write this, all of those x's, using one exponent, that would be x to the 10th. That's x to the 10th power. So, when you look at this, how do you get from the start to the end? You multiply your exponents. So, we multiply the exponents. So you multiply the exponents when you have a power raised to a power. When you have a power raised to a power. So, the property of raising a power to a power, to raise a power to a power, we multiply the exponents. Make sure you have that written down. You multiply the exponents. So, if you have a to the m raised to the n, it would be a to the m times n. And here are a couple of numerical, here's a numerical example. So here we have 5 to the 4 raised to the 2nd. So that's going to be 5 to the 4 times 2, which is equal to 5 to the 8. Does everybody see how I expect to see your work? Okay, that's how I expect to see your work. Over here we have m to the 3rd to the 5th. That's just going to be m to the 3 times 5. And then when you simplify that, you get m to the 15th. Okay? So, question here, does the property for a power of a power apply to a positive and negative exponent? You think it applies to both of them?
Yeah.
Yeah, because look, here if I expand this out, this is going to be 2 to the negative 3 twice, right? So we're going to say, we're going to have 2 to the negative 3 times 2 to the negative 3. Now, what do I do when I multiply powers? What do I do with those exponents? You add them, right? When you multiply powers here, you're going to add them. So this is going to be 2 to the negative 6. So you can see negative 3 times 2 is negative 6. Is that simplified, by the way? No, what do I have to do to it? You need to flip it. Very good. So then this would end up 1 over 2 to the 6th. And if it said simplify, you would multiply it out, right? If it said write it using one exponent, then that's how you would write it. Or one base, you would write it like that. So problem 1 is simplifying a power raised to a power. what is the simplified form of each expression? So I've got 3 of them now. What is the simplified form of each expression? So, Aiden, what do you say for letter A?
To the 20th.
Very good. And to show our work, we're going to have p to the 5 times 4, which is equal to p to the 20th. Yes? Same thing, right? Same thing. So here, this is going to be p to the 4 times 5 is equal to p to the 20th. Okay? How about this one down here? That one's going to be p to the negative 20th. So that's p to the negative 5 times 4, which is equal to p to the negative 20th. Problem 2. Here we're going to use the order of operations when we simplify an exponential expression. So simplifying an expression with powers, we want to know what is a simplified form of each expression. So, order of operations, Prendoff tells us that we have to do parentheses, exponents, then multiplication and division from left to right, then addition and subtraction from left to right. Correct? So here, this parentheses doesn't really mean a grouping symbol, right? That just separates. That's just separating this. So here we've got the exponent that we're going to do first. Okay? So we're going to do the x to the 6th to the negative 4th first. So this is going to be equal to x squared times x to the 6 times negative 4. You could just do that part in your head down, right? So 6 times negative 4, that's negative 24. And now we can do the multiplication. So here now we're multiplying powers. What do I do when I multiply powers? You add the exponents. So we have x to the 2 plus negative 24. And so my final answer will be x to the negative 22. Actually, that's not the final answer because we want to simplify this, right? So now we need to flip this. Bless you. So we need to flip this. So our final answer then becomes 1 over x to the 22nd. So for example B, we have w to the negative 2 times w to the 21st. That's not a negative up there, okay? I'll clear that out. That's 7 times 3. So it's going to be a positive 21. Now here, what do I do when I am multiplying powers?
You have to add them.
You add the exponents. So we've got w to the negative 2 plus 21. So that's going to be w to the 19. And you're done. For this letter C, we're going to do this one first. Okay? So, this we get r to the, I'm going to just show all of the work. R to the negative 5. Well, actually, I don't need to. Negative 5 times negative 2 is what? Positive 10. So it's going to be r to the 10th. So it's going to be r to the 10th times r cubed. And now I'll show the work for this. So we've got r to the 10 plus 3, which is r to the
13.
And you're done. All right. So here you can use repeated multiplication to simplify an expression like 4m to the 3rd power. Here, this is a product, see, because you're multiplying in the parentheses, a product raised to a power, okay? So, if I multiply this out, and if I expand it out, if I expand this out, this is going to be 4 to the m times 4m times 4m times 4m. Okay? 4m times 4m. So what am I going to do here? What exponents do I have on these m's?
Ones.
You have ones here, right? And what do I do when I multiply powers? You add the exponents. So this is going to be m to the third power. What do I do to the fours?
You add the one.
You multiply the coefficients. So this is going to be also 4 to the third power, right? When you simplify this, you're going to get 64m to the third power. Now, I want to point out to you, going from this to this, okay? If you look at that 3, the exponent 3, it applies to the m and the 4. Does everybody see that? So when you have a product raised to a power, the exponent gets applied to everything inside the parentheses. All right, so this example illustrates another property of exponents, and that property is the product raised to a power. And here's the rule for a product raised to a power. To raise a product to a power, you'll raise each factor in the power, and you will multiply, So here we have a times b raised to the nth power. We're going to have a to the nth times b to the nth. So the exponent gets applied to everything inside the parentheses. So over here, 3x raised to the 4th power, that's going to be 3 to the 4th, x to the 4th. So, and then when you simplify, 3 to the 4th is 81, and then we have x to the 4th.
You're going to be repeating yourself. Ah, you recorded it.
Okay, to raise a product to a power, you're going to raise each factor to the power, and then you're going to multiply. Okay. All right, so problem 3 is simplifying a product raised to a power. So now we're just going to apply what we just learned. So here, I guess we can go quicker on this, right? This exponent 3 will be applied to everything inside the parentheses. So we will end up with 7 to the 3rd times m to the 9th to the 3rd. Okay? Now, this is a power raised to a power. What do I do when I have a power raised to a power? You multiply the exponents. So this will be 7 to the 3rd, and then m to the 9 times 3, which is 27. And then we can simplify 7 to the 3rd. So 343 m to the 27th is your final answer. Everybody good? All right. For example B, again, the -4 will get applied to everything inside the parentheses. Okay? So this will be 2 to the -4th times z to the -4th. What do I do when I have a negative exponent? You flip them. So that means that this is coming down to the denominator and this is coming down to the denominator. When I bring those down to the denominator, what goes to the numerator?
1.
1. Very good. So we end up with 1 times 1 for both of them, which is just 1. So we're just going to put 1 over 2 to the 4th, z to the 4th. So when you flip them, the exponents become positive. Okay? And now we just multiply 2 to the 4th, which is 16. right? So that's going to be 16z to the 4th. For example, C, because the negative is connected to the entire parentheses, can I just flip the whole thing altogether? Yeah. So this is going to be equal to 1 over 3g to the 4th, now to the positive 2. Okay? And now we can apply that 2 to everything inside the parentheses. So this becomes 1 over 3 squared g to the 4 squared. Got it? And then when we simplify, we end up with 1 over 9g to the 8th. Very good. 9g to the 8th. Problem 4 is simplifying an expression with products. Ooh-wee. What is the simplified form of each expression? So on this, we're just putting everything that we've learned together. Okay? We have a power raised to a power, and then over here on the second factor, we have a product raised to a power. Okay? So when I have a power raised to a power, what do I do to the exponents? You multiply them. Very good. So this is going to end up with x to the negative 2 times 2 is negative 4, right? And then over here, we're going to apply this 4, this exponent, to everything inside the parentheses. So we end up with, so times 3 to the 4th times x to the 4th times y to the 5th to the 4th. All right, so now we're going to deal with that exponent. So here I have a power raised to a power. When I have power raised to a power, what do I do to the exponents? You multiply them. Very good. Now, in addition to doing that, can I put these x's together?
Yeah.
When I have a power times a power, what do I do to the exponents? You add them. Very good. So, here we've got x to the negative 4 plus 4. That's going to be x to the 0. Then we have times 3 to the 4th. And then over here, y to the 5 times 4 is going to be y to the 20th. Well, of course, any number raised to the 0 is equal to 1. Very good. So that's 1. So 1 times all of this is just all of that. So we end up with 3 to the 4th, which is equal to 81. And then we bring down the y to the 20th. So for this one, for letter B, we're going to apply that 4 to everything inside the parentheses, and we're going to multiply those powers. So we end up with 3 to the 4th, c to the 5th to the 4th, times c to the 2 times 3, which is c to the 6th. And now, using our order of operations, we're going to deal with that exponent in the middle. Okay? Can I go ahead and multiply 3 to the 4th right now?
Yeah.
So 3 to the 4th, of course, again is 81. And then when we have a power raised to a power, what do I do to the exponents? Right, you multiply them. So we're going to have c to the 20th times c to the 6th. And now I have a power times a power. What do I do to the exponent? You add them. So this is going to be 81c to the 26th power. So you can use the property of raising a product to a power to solve problems involving scientific notation. So this says 3 times 10 to the 8th power, all squared. Okay? Which means that this exponent is going to get applied to everything inside the parentheses. Is everyone with me? So, this 2 is going to go to that, and it's going to go to that. So we're going to end up with 3 squared times 10 to the 8th squared. And then you just simplify. So 3 squared is equal to 9 times 10 to the 8th squared is 10 to the 16th because it's 8 times 2. So that's going to be 10 to the 16th. And there's your scientific notation. Problem 5. Problem 5 is raising a number in scientific notation to a power. The expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an aircraft with a mass of 2.5 times 10 to the 5th kilograms traveling at a speed of 3 times 10 to the 2nd meters per second? All right, so we substitute the mass right there, there's our mass, in there for m. So we have 1/2 times 2.5 times 10 to the 5th times, now we're going to substitute the velocity, which is right there, meters per second. So times 3 times 10 squared, and that whole scientific number is squared. Over here, we're going to take that exponent over there, and we're going to apply it to everything inside the parentheses. So we've got 1/2 times 2.5 times 10 to the 5th times 3 squared times 10 squared squared. So because all of this is times, we can multiply in any order we want to. So I'm going to multiply the 1/2, the 2.5, and the 3 squared. Okay? Now I'm just going to reorder it. I'm just going to write them all out. So we've got 1/2 times 2.5 times 3 squared, which is
6.
9.
That was not recording, right? Oh, God.
Times, now we're going to multiply the powers. So over here I'm going to put 10 to the 5th times 10 squared. Squared is 10 to the 4th. Very good. So one step at a time, right? So now we can multiply this first part. So this right here is going to be 11.25 times here, when I have 10 to the 5th times 10 to the 4th, that's just a power times power. What do I do to my exponent? You add them. So this is going to be times 10 to the 9th power. But is that in scientific notation? No, it's not. So what do I need to do?
Move the decimal to the left.
Move the decimal to the left one. And when I move to the left, what do I do to the exponent?
Add 1.
You add 1. Very good.
Oh,
So our final answer is 1.125 times 10 to the 10th power. And that is going to be the kinetic energy in joules.